Hey, it's Dr. J. 6.5 today, the properties of logarithms. Until we're getting close to the end of the chapter, and we're going to start using these properties to expand and to compress equations and expressions involving logarithms and eventually solve some equations. But today we're just going to exercise a few properties. I'll go through them one at a time with examples. So property number one. The logarithm let me start over again. The sum of two logarithms, as long as they have the same base. So I'm just going to say base A for all of these examples, for all of these properties. The sum of two logarithms, as long as they have the same base, is the product of their arguments. So it becomes one logarithm where the arguments are multiplied. Okay. When we go this direction, it's sometimes called compressing, because it almost feels as if you're taking two things and squishing them together into one object. When you go back the other direction, it's sometimes referred to as expanding. So we have sort of two ways of looking at this property. It just depends whether you're going from left to right, compressing, or whether you're going back the other direction, expanding. Let me write down all the properties, and then we'll use them. There are three properties today. Or three in this presentation. There are certainly going to be more than three by the time we're done, but three on this page. So sum, the next one is the difference. Difference of two logarithms, they must all have the same base. And A is, of course, greater than 0, some base A. Some books, and if you Google this or if you look these formulas up on the internet, they often will use base B just because the word base starts with the letter B. But I've been using A ever since we started chapter 6.1. So I'm going to stick with A. So the difference of two logarithms is the quotient of their arguments. X divided by y. And again, if you go this direction, it's compressing. If you go the other direction, it's expanding. The third property is the log of an argument that's raised to a power. That is equal to the power times the logarithm. And I should mention on this left-hand side here, sometimes we write it this way. And these mean the same thing. So if I say log A xn, or if I say log ax to the n, these mean the same thing. We often omit the multiplication dot and just put the letter n. That's the power n multiplied. It's implied that that means multiply. So this property often has different ways of writing the property, but they mean the same thing. Again, you know, I always say tomato, tomato, right? Okay, so these are the three principal properties. Primary properties, fundamental properties. So we'll take a good look at them. If you forget them, there's a very easy way to remember them. Just think about exponents. Now, this does require that you remember the rules of exponents. So you're not going to get it completely free, but I think the rules of exponents hopefully have been, hammered home so many times over the last, I don't know how many years you've been in school, that you have those pretty well, understood or at least memorized to a point. So, I mean, if you forget the sum rule, all you have to do is remember the rule of exponents. Well, if you had ax and ay, well, that would be the same as ax plus y. So this is the same as property number 1. Yeah, the sum and the product. Yeah. Yeah. Similarly, suppose you forget the quotient rule. Well, hopefully you won't forget the quotient rule from arithmetic or from exponentials. If you have a quotient, that's another way to say a fraction, well, you subtract. So a quotient becomes a difference. That's property 2. Okay, because I'm going to erase all these properties, and I want to be able to recall them in 5 minutes or 5 years or 5 months or 5 days from now. And then the last one would be if you had a to the x and then some multiple, some power of n. Well, then you would multiply a x times n. Or we often write a n x. Again, tomato, tomato, these mean the same thing. Okay? So this is sometimes called the power property. So a power becomes a product. I don't know if you can see that. There you go. You can see that down here at the bottom. All right, so let's just look at some examples. We'll start by doing some compressions. We call that also combining into a single log. I have a few different examples. How about log base 2 of y minus log base 2 of 5? Well, I blurred out a little bit. Come back to me. There we go. Hopefully that wasn't blurry for too long. All right, so combine into a single logarithm. I'm just going to write down one of these at a time. All right, so this is subtraction. So that's going to be a quotient. That's it. Just exercise the properties. We'll get good at these as we go through them. So here we have a sum of the logs. Do a single logarithm. We're going to have the product of x times x plus 4. In this case, you can omit the dot because the parentheses will act like the multiplication dot. I do like to use the distributive property here so that you can type your answer in like this. Although either one of these should be marked correct, I prefer if you simplify it as much as possible. started to write x. Now, one thing I want to make very clear before I even do this problem, and go back to part B here, what you cannot do is distribute the word log. The word log all by itself does not function like a coefficient. It cannot be distributed like that. So never do this. That's really important because I'll give you some problems as we move through that it looks tempting to take this word log and go like that. Don't do it. Don't even think about doing it. Yeah. What you want to do is just use the property. This is a common log. If you don't see a base, we assume that it's 10. All right, you don't have to put the 10, but in your mind, you know that that means base 10. And now we're using the quotient property. That'll be c squared minus 4 over c plus 2. Parentheses for good measure. And then I want you to simplify this as much as possible. So that'll be c plus 2, c minus 2 over c plus 2. And simplify the final result will be log of just c minus 2. And you got to know when to stop. If you go too far, if you keep inventing properties that don't exist, you'll end up taking a perfectly good answer and screwing it up by not knowing when to stop. Okay, so that's it. Your argument is c minus 2. It's a common log base 10, and you cannot go any further. All right, so that's the first two properties, a couple examples of those. Let's do one. We'll make this one just a single part. Okay, example 2. It's very similar to example 1. The only difference is that these have coefficients in front of the logarithms. These are natural logarithms. And we're going to do the same basic thing. We're going to combine them into a single log. But you must first use property 3, the power property. And the power property essentially says that a coefficient becomes an exponent. It's a property of logarithms. So you must do that first before you try to employ any of the other properties. Now you can put the exponent outside of the parentheses. Or you can bring it inside of the parentheses. It means the same thing. It's another one of those tomatoes. These mean the same thing. Okay. Once you've gotten those exponents removed from the front of the logarithm, now you can do the next property, which would be the product to sum property, or sum to product. I don't know if that was property 1, was it? Doesn't really matter the order that you learn them in. Some people put them in a very specific order. Other people just say know the properties. Sometimes we insist that you know the name of the property. So the sum becomes a product. So ln of x squared times 2 to the third. Or you could use two sets of parentheses. I'm using a dot as long as it's clear that you're multiplying. In fact, you could even just do nothing. That is multiplication in mathematics. Okay, and then simplify this as much as possible. So this would be x squared times 8. If you really insist, you can leave your answer like that, but most of us prefer to see it in the traditional 8x squared. All right, and parentheses are required when you type your answer on the computer. They're not required in your notes. So if you left the parentheses off, it would be okay. I would mention one thing. If you write it like this, it would not be correct. Because that would mean that you're squaring the 8, and squaring the 8 would turn it into a 64, and that's, of course, not the correct answer. So if you're going to use parentheses, well, you do have to use them on the homework. Put them outside of the exponent for your final answer. Okay, that's just a one-part answer, or one-part problem. Let's move on to example 3. Yeah. So we often like to rewrite logarithms or logarithmic expressions without any exponent. So rewrite the expressions without exponents. Now, it's not as if the exponents go away. They never really go away. They just move to a different location. So when I say without exponents, I mean without being in the exponential position. That's really what I mean. I don't just mean delete the exponent. That would be ridiculous, right? So this time, instead of putting the power up, we're using the power property the other direction. Power becomes product. Yeah, we often just call that the power property or the PP property, power to product property. So that -6 comes down to the front and becomes a multiplier or a product of the log. We typically omit the multiplication dot just for simplicity, but if you want to type the dot, I think it's shift 8. Yeah, it'd be a star. Looks like a asterisk or something like that. That would be the symbol for the multiplication if you choose to write it. I typically don't. I only write it if I'm trying to make a point. Get it? Make a point. It's not very funny, but it's okay. I didn't think anybody would laugh. So moving on to this one, we have 2 exponents in 2 different positions. Okay. You can't bring them both down at the same time. All right, one at a time, please, one at a time. All right, so the first thing we're going to do is just rewrite this as a quotient. So we might use combinations of properties here. So first we go from quotient to difference. I think that was property number 2 in our list. And then we can do the power to product property by bringing the power down to the front. So I got 3 log base 2 of x minus 4 log base 2 of y. And so we have followed the directions. We have written the log without any exponents. One thing that's very important is the order in which you do things. Okay, so notice that I had to first perform the quotient to difference property, and then I could do the power property. All right, if you do them out of order, you'll typically get some sort of error message or some sort of incorrect result. Look for parentheses. Read the directions. These are all things that you can do to make sure that you're doing it in the right order. We don't have a cute acronym like "Please excuse my dear Aunt Sally" to help us remember the order of operations. It's what we call an implied order of operations. In other words, it's subtle. It's implied by the description of the problem and what's being asked that there is an order to doing things. You know, it's kind of like socks and shoes, you know. They don't put instructions that tell you you have to put your socks on before you put your shoes on, right? That order of operations is implied by the nature of the problem. Okay. So we don't always explicitly say that. So write as a single logarithm. Back to the original objective, which is to write this as a single logarithm. 3 log base 7 of x plus log base 7 of 4 minus log base 7 of 8. Okay. So there's an implied order here by the parentheses. So it's a little bit like basic arithmetic. You know, you do what's inside the parentheses first, and then you do the exponents, and then you do your multiplications and things like that in that order. But sometimes the order goes a little bit differently than that. So that's why we don't use a PEMDAS kind of thing. We just kind of say, well, do whatever the problem is telling you to do. Okay. So the first thing it's telling me to do is use the sum property, because that's the inside parentheses. We're going to do that first. So we're multiplying the arguments x and 4. Okay. Now this extra set of parentheses are redundant. You don't need double sets of parentheses here. So we typically get rid of those. We also don't like the way x4 looks. You know, nothing personal, but it just looks too complicated, or it looks like it might be an exponent, right? Especially if you're writing very quickly, it's dangerous. It might look like that. And you don't even want to take that chance. So we've been doing this for a very long time in algebra. When you see x times 4, you always write it as 4x. And now we're going to do the power property. I don't want to forget about this guy over here. He's going last. Power property. Okay, and then finally the quotient property. So the quotient difference becomes the quotient of a single logarithm. Now you should try to simplify this. This is correct. This is not simplified yet. I basically just have a general rule that you should always simplify if it's possible. It's the if you can, then you should rule. All right, can we simplify that a little bit? Just a little bit. Not much, but we could simplify a little bit. So let's simplify that. Log base 7 of 4 cubed x cubed over 8. All right, see this exponent of 3? You have to exponentiate both the 4 and the x. So now you get log base 7 of 64 x cubed over 8. 4 times 4 times 4 is 64. And then 64 divided by 8 is 8. And there you go. That's a 3. I'm not sure if that's clear. Now, in previous examples, I had made a statement that it didn't matter where the exponent was written. That's only if the argument is one factor. This argument has 2 factors, 8 and x, and so the exponent must be there, yeah, on the inside. If you wrote it this way, it would be incorrect, because there's 2 factors. If there's one factor inside the argument, well, then it doesn't matter. I call that tomato, yeah? But if there's two or more factors inside the argument, then where the exponent, the position of the exponent is important. Yeah, so don't write it this way. That would actually mean 8 times 8 times 8. That's not what we're doing. We're doing x times x times x, but we're not doing 8 times 8 times 8. I'm just leaving it as 8x cubed. Okay. So that would be the simplified answer with exponents. You could also write it without exponents. If asked to write, now this problem didn't say that, so it just said single logarithm, so we are done, but this is just a little, note, star note here. If you're asked to write without exponents, like we did earlier, just go back and read it and see if it's asking for no exponents. Then you have to get rid of that third power right there. So you would write it as 2 to the third. Yeah, the 8. 8 is 2 times 2 times 2. Then you can remove the exponent. And then you can pull it down using the power property. So this would be the correct answer if you were asked for no exponents. If it just said simplify or write as a single logarithm and there was no direct instruction as to what to do with the exponents, you can assume that you can keep the exponents. So I don't want to say that this problem has two answers. This problem has one answer, one result, but it also has a side note, corollary, just in case you're being asked to do that. So I want you to write the next one as a sum or a difference without exponents. Basically what I was just describing. Log base 3 of x to the 9th times the square root of y to the 17th. Square roots. Now, we're just using square roots symbolically. I'm not actually going to ask you to take the square root of anything today. But symbolically, what a square root means, it means 1/2. As an exponent. So this symbol becomes a 1/2 power. So you might want a little note here. Cube root would be a 1/3 power. Fourth root would be a 1/4 power, etc., etc., etc. I don't think we're going to do anything more than, square roots, cube roots, maybe the occasional fourth root. Think about the previous chapters. We learned all about the functions and the mother functions. We pretty much focused on the square root and the cube root. Those are the ones that I'm going to test you on. So, I mean, there are other roots, but they're just not in this setting today. Okay, so this is a square root. First, we're going to use the product property. We're going to turn that into addition. Okay, then we're going to use the power property and bring the powers down. Now these powers, 17.5, don't write it as 17.5. Write it as 17 over 2. That's not the same as 17.5. That's more like 8.5. Yeah. You could actually write 8.5 if you want. It just looks funny. So we write 17 over 2 just because it looks nicer than 8.5 or something. But if you really want to be weird and you want to type 8.5 instead of 17 over 2, it's technically still correct. I'd still mark it right. Whatever you do, don't write 17.5 because it's not. It's 17 times a half. You're multiplying the exponents. 17 multiplied by 1/2. Okay. So there's your answer. It's a sum or a difference. In this case, it's a sum. I give you two options just in case your problem is slightly different. Keep going, yeah. Example 7. Same question. Write as the sum or the difference, depending on which version of the problem you get, without exponents. X, Y, Z. So we have 3 variables here and 3 different exponents to get rid of. Okay. Exponents typically go last. All right. That's the last thing you're going to do. I know. That's why we don't do please excuse my dear Aunt Sally, because in that order, exponents would be second. All right. We're going to first use the sum or the difference properties. Then we're going to do the exponent properties last. It's one of the reasons why when I gave you the 3 properties, I put that property last, okay? So first we're going to do the difference. If you don't see a base, assume it's 10, so just write log. Difference, so we have x squared, y to the 10th, minus z to the 5th. I put a slash through my z's so that they don't look like 2's. Now I'm going to go sum. Yeah, sum. So this product becomes a sum. And finally, without exponents, I'm going to take all of these powers and bring them down to the front. Respectively, each logarithm has its own, what we call the front. Right in front of the letter L, we call that the front of the log. Okay, I guess one more of these, and then we'll shift gears a little bit. I should point out before I move on, because I feel like I'm going to get ahead of myself if I don't say this now, properties are also called laws. So some questions will say, use the properties. Other question will say, use the laws. Laws and properties are synonyms in mathematics. They basically mean the same thing. When you get really high up into mathematics, there is some subtle differences between properties and laws. But at the freshman, sophomore college level, a property is a law is a property, and they're the same thing. Okay. So use the properties to rewrite and simplify. As the sum or difference, again without exponents. Let's do a logarithm naturalis of the cube root x squared minus 9 over x plus 5 to the 12th power, excuse me, all divided by x minus 3. Oh, and parentheses. First thing we should try to do is simplify inside before we start expanding this out. Okay. Whenever I say write as the sum or the difference, that's sometimes called expanding. So before I do that, look for any basic math tricks that you can use or techniques that you learned that will make this problem a little easier. You can simplify it early, and that'll save you some steps later in the process. If you don't notice that now, you might notice it later on, but you might not. So let's just go ahead and do that first. I'm not going to give you anything that's not basic algebra at this point when it comes to this type of technique. So I don't know if you notice my strategy is to give you simple problems that are dressed up in the new outfits of logarithms and exponentials, but inside of the problem that I give you, it'll always be something simple. That's mainly so that when you're doing the problem, you can tell yourself, this should be simple. It has to be, otherwise you're in the wrong class, right? So it is, right? X squared minus 9. I think while I was talking, I clearly showed you how simple that was. X squared minus 9 is x minus 3 and x plus 3, right? Basic arithmetic. 3 times 3 is 9, yeah? Positive 3, negative 3 gives you negative 9. So now you can simplify this. The problem's going to get a heck of a lot easier already. So now we have ln of the cube root, and now there's no more denominator. That makes things really nice. I mean, nothing wrong with denominators, but, you know, denominators are like fractions, and people typically make small mistakes with fractions. So if you can get rid of the denominator, you're less likely to make a mistake. Now you're going to take the 1/3 power and bring it outside. A cube root becomes a 1/3 power. So I'm not going to write the cube root symbol anymore. That's a 12, right? Yeah, 12th power. Okay. Now we have the ln of x plus 3 to the 1/3, x plus 5 to the 12/3. So 12 and a third, and then there's an invisible 1 and a third. So this third root is going to apply to both of these. Both factors in the argument. I think a few minutes ago I did one where it came out to be 17/2, right? Well, 17/2 is irreducible. You can't rewrite 17/2 without using a decimal. 12/3 is reducible, so you should just go ahead and do that. That's going to be 4. Yeah. Again, simplify always if possible. It's not always instructed directly, but sometimes you just have to know if you can do it. Look at it and say, can I do it? Well, if the answer is yes, I can, then you should. Yeah. All right, we're getting there, kids. We're almost there. So now we've got a product. So that's going to be ln x plus 3 to the 1/3 plus. Yeah, product becomes sum. ln x plus 5 to the 4th. And then finally, we're home free now. We take our exponents and we bring them down to the front of the letter L. That's what we call the front of the logarithm. It's very important that you keep the parentheses around the argument. If you don't type the parentheses around the argument, the computer will think that you mean ln of x plus 5. That's what it'll think. But you want it to be ln x plus 5, like all bundled together, x plus 5. So there's your answer. There's your result. It's been expanded. There are no more exponents, and it's completely simplified. Okay, so those are the basic properties, the fundamental the ABCs or the 1, 2, 3s of logarithms. Now we're going to sort of dive in the deep end a little bit, get out of the shallow end and get into the deep end and start swimming with sharks. Sometimes I wish I could rewind and check my work. I got so far ahead of myself. I think we're at example 8, but I might be on 9. I'm not sure. All right, so rewrite as a single logarithm then evaluate without a calculator. Calculator, there we go. All right. Now, you're at home and I can't see what you're doing and I'm not spying on you through your webcam. So, if you want to have your calculator out to make you feel safe, or if you want to use it to check your answer or whatever you want to do, I'll leave that up to you. Okay. But the intended method is that you can do this mentally. So if you want to train your brain to be operating in logarithmic mode, you should try to follow the directions and do it without a calculator. But, between you and I just want you to get the right answer. So I'm going to do it without a calculator just to demonstrate good form. Assume these are all base 10, because if you don't see a base, that's understood to be the common log. All right, so now we actually have something here that we're going to produce a final answer, right? So everything up until now was just training, right? This is, now you're in the game here. Okay, we want an actual numeric answer, 12 or 5 or -2 or whatever it comes out to be. I don't know, we'll see. All right, let's use the properties here. We've got 5, 2. Notice that I just leave the negative behind and I think of that as just 2. Yeah. There is another technique that maybe I'll illustrate in a moment, but for now I'm using the technique that I've already been illustrating. And on this one, there is no exponent, although if you really want to be the life of the party, there's an invisible 1. Everybody has an exponent of 1, but I'm not going to go there. There's no exponent. It's 1. In other words, we don't have to follow any law if there is no exponent. So log of 20 to the 5th power, log of 4 to the 2nd power, minus log of 2. I have 3 terms. I should do them 2 at a time. 2 at a time. So there's a trick here. Look at these negatives. Yeah. I've got two negatives. So I'm going to end up dividing twice. But there's this little trick of arithmetic that dividing twice is the same as multiplying. You're dividing and then you're dividing again. So I can remove the negative, factor it out, so that I only have to divide one time. And then the second negative sign, that second division, will then turn into multiplication, because it's like you're doing the reciprocal again of the quotient, which turns into the product. That trick is just to save you time. If you don't do that trick, you're not necessarily going to get the wrong answer. You're just going to have to fill up a lot more paper to get it. So that one step is probably going to save me 5 lines of work here. So first I'm going to do what's inside the parentheses. Notice that 20 to the 5th is a very big number, so I'm not actually going to do it. I'm just going to write it as 20 to the 5th. Now I'm going to write this as a product, log of 4 squared times 2. All right, now I have to fold the exponent inside because it's being squared. I don't want to put the squared on the outside because that would be misleading. The directions would be lost. All right, and then now we only have one quotient instead of having 2 quotients, which would have gotten very confusing had I not done that trick. So now I've got log of, let me just rewrite it one time here. Log of, let's see, what do we got? 4 squared times 2. I'm just going to leave it as 4 squared times 2. I was considering multiplying that, but I mean, if you're not intimidated by giant numbers, then you could go ahead and multiply the 20 times 20 times 20 times. It's not that bad. I mean, you do have a calculator, but it said not to use it. So, and then this one you can probably do in your head. That's 32, 16 times 2. I'm going to finish simplifying before I start evaluating. So now I've got subtraction. So that's going to be 20 to the 5th over 4 squared times 2. Subtraction becomes quotient or division. I've got a little extra space here. I know normally I work down, but since I've got extra space, I need to use it. So 20 to the 5th. 20 to the 5th is 4 to the 5th times 5 to the 5th. Okay, maybe I'll do one of my famous thought bubbles here. Remember, I used to do these in class all the time. If I show something that's done mentally, I want to give you a glimpse into how I thought through that. 20 is 4 times 5. I know 20 is also 2 times 10, but look at my problem. I have a 4. So, go with what you got. If I would have had a 10, then maybe I would have done 2 times 10. But I've got a 4 here, so I'm going to do 4 times 5. So 20 to the 5th is 4 times 5 to the 5th, which is 4 to the 5th times 5 to the 5th. And so that's how I was able to make that leap from 20 to the 5th over to there. It's all downhill from here. You've already summited the mountain. And now you just coast home. So 4 to the 5th divided by 4 to the 2nd, that's going to be 4 to the 3rd. Remember, division is the same as subtraction, so I'm subtracting those. 5 to the 5th over 2. All right, so what do we got here? we've got a really big number here. 4 to the third is 64. 5 to the fifth. I'm trying not to use the calculator. Let's see what we can do with this. So now I've got 4 to the third. That's the same as 2 to the sixth. Again, another mental leap. How do I get from 4 to the third to 2 to the sixth? Well, you do it with a mind cloud. Yeah, that's how you do it. It's a mental leap. Let me write it all out here. 4 to the third is 2 times 2 to the third. Yeah, because 4 is just 2 times 2. Well, that's 2 to the third times 2 to the third, because you have to apply the power to both of the bases. And then you add the powers, and that's 2 to the sixth. And if you don't believe me, you can actually do it. Yeah? 4 times 4 times 4 is 64. That's exactly the same as 2 times 2 times 2 times 2 times 2 times 2. 6 twos. I think that was 6 twos. And I know at this point you're like, really? Are we there yet? Are we there yet? We're almost there, okay? We're going to use the quotient property one more time. We have 6 divided by 1. 2 to the 6th divided by 2 to the 1. So we're going to subtract those. Six minus 1, you're going to subtract the powers. And that gives you 2 to the fifth. Ah, look. We're starting to get somewhere now. Yeah. That's the same as 10 to the fifth power. 2 to the fifth times 5 to the fifth. Well, what's 2 times 5? 10. So that's 10 to the fifth. And now, finally, the grand finale, the power property. So this 5 is going to come down to the front, and I'm going to get 5 log 10. And I just went out of my window here. 5 log 10. And then read this. What power of 10 is 10? In other words, 10 is 10 to what power? 1. Yeah. Remember, logarithms are asking a question, what is the power? The power is 1. And so after all of that work, you get a simple result of 5. All right. You know, sometimes you have to use your calculator. You know, sometimes there's just no way around it. So I'm going to show you an example of how to get a decimal. In fact, one thing that I notice on a test, or even on the homework sometimes, but it's mostly on the test when I'm looking over your answers and trying to see if I can give you a couple extra points, or to see if there's something that was correct that maybe you typed, with a comma instead of a period or something like that, or a decimal point. If something like this, I can tell that you used your calculator, because your calculator will often give you 4.999999 or something like that, or 5.001, or typically there's a little bit of error with a calculator. You get approximation error, we call it. And occasionally you'll get an exact answer like this, but I mean, that's kind of how I know, right? So I put a problem on the test and I say, do it without your calculator, and you give me 4.999, I immediately know you didn't follow the directions, because there's no way you're going to get 4.9 if you actually follow the directions. But if you use this is a decimal machine, and it typically gives answers in the forms of decimals, right? But I still want you to know how to use your calculator. So let's do an example. Again, I might have lost track. I might be at example 10, but we'll see. I'll edit this at the end if I have to, or make some, I don't know, notations or something if necessary. So use your calculator to find the value. And we're going to round to the nearest, I don't know, what should we go to? Nearest hundredth? Nearest, now we're going to go 4. I almost didn't read it carefully. I was going to do 2, but 4 decimal places. I think I'm thinking down the road a little bit when we'll go to 2 decimal places, but right now we're going to go to 4. It's better to have too many than not enough. So, and so I'm going to give you a problem that cannot be done without a calculator. Log base 2 of 10. Yeah. So again, this is asking a question. What power of 2 would be equal to 10? Right, well, you can play around with it a little bit. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. And notice you'll never get 10. It skips right over 10 and jumps to 16. So in my mind, I know that my calculator should give me a decimal somewhere between 3 and 4. So somewhere between 3 and 4. So there are 2 ways to do it. You can use the common log button. That's the button that just says log. It's right here on my calculator. It says LOG. So you do common log of 10 over common log of 2. So the base goes to the denominator. And then leave the argument in the numerator. And just do it on your calculator. So I got log of 10. That's 1. I didn't need my calculator for that, but I did it anyway. And then log of 2 is 0.301. All right, I'm going to write it down, 301029996. And then I'm going to divide that on my calculator, 1 divided by, and then I'm going to approximate 3.3219, 4 decimal places. Notice it's somewhere between 3 and 4. Yeah, this is a decimal between 3 and 4. Okay, or you can use the natural log. You have typically, most calculators come with 2 log buttons. You have the common log and then you have the natural log, the ln. They're usually right next to each other. Same thing, you're going to put the argument in the numerator and the base in the denominator. And we already know the answer. I'm just trying to give you options. So you might wonder, why are there 2 buttons on there? You know, you have 2 possible ways to do these problems. So ln of 10, I'm using the ln button this time. That's 2.302585093. Don't round until you're done. So do keep the entire screenshot there. Ln of 2. 0.693 9314781, and then divide these on your calculator. 0.585093. And what do you know? You should get exactly the same answer either way. I don't really need you to do the problem twice. Just pick which way you want to do it. But it's good to have options so that you know if one problem gives you, or one method gives you one answer and another method gives you a different answer, that's a clue that one of them's got to be wrong or maybe both of them are wrong. If these agree with each other, that's like a full confirmation that you know that you've done it correctly. Or at least you may, I mean, you could have still made a mistake, but it's highly unlikely that both of these would agree with each other if you made a mistake. You know, usually the mistake will come out in the wash somewhere. All right. Okay, this is a very minor topic. It's just so that in the event that I do want you to use your calculator, I want you to know how to operate the two buttons on your calculator to give me decimal answers in case it becomes necessary. I'd say for the most part, 18 out of 20 questions do not require a calculator, but there's a few questions that do. All right, we're done. Well, we're done in a second. We got one more example. Example 10. I saved the best one for last. Suppose you already knew. Suppose you were already given some information. Suppose you know that ln of A is 2, ln of B is 3, and ln of C is 5. What would the value be without a calculator of the following quotient? What would this result be if you know these three values? Yeah. So this is kind of like a throwback problem from the 80s. You know, when this class was taught back in the 1980s, oftentimes a teacher would give you a handout. I know my teacher gave me this booklet. It was probably like 40 pages of logarithms written out in this form. Yeah, so that you just were pulling these numbers off of a handout, and then you would insert those numbers into some larger formula and then exercise out the result. We don't do that too much anymore. It's kind of an old-fashioned way of doing it, but I wanted to put that out there to give you the experience of taking pre-selected values. They're typically selected by your instructor, and then inserting those values into the equation. Now make sure you wait to plug them in. All right, don't plug them in now. If you plug them in now, it's definitely going to be wrong. It'll be wrong every time. Okay. Now this is a quotient of two separate ln's, so you have to do the numerator and the denominator separately. Okay. If this was one logarithm, if it was like this, then you would not have to do them separately. You could combine them all together and do them all at once. But because these are two independent logarithms, one's on top, one's on the bottom, they cannot be combined. All right, you have to do them separately. It's a little bit of a chore, but there's worse things to do. So the numerator, let's do that. So we have ln of a to the negative 2 plus ln of b to the third. I'll finish that in a second. The denominator, we're going to pull down the negative 1. And we got ln of bc with a negative 1 out in front. I guess I could use parentheses or a dot, something to indicate that that's being multiplied. This is one of those exceptions where I actually do write the dot, because look what it looks like if I don't. It looks like double ln, like an ln with two l's. like a llama. Yeah. I'm going to wait to plug these in. I don't want to forget them, so I'm going to write them over here. Just hang on to these for later. All right. We'll be right with you. All right. Stay on hold. All right. Finishing off the numerator, we can pull down the exponents. So we get negative 2 ln of a. I'm going to go ahead and put parentheses around the a and the b. Plus 3 ln of b. All over. Now I'm going to do the denominator, negative 1 times ln of b plus ln of c. And I got a lot of parentheses in the denominator. Now we can plug everybody in. So now we've waited. We can plug in ln of a. So everywhere you see ln of a, replace it with 2. Everywhere you see ln of b, replace it with 3. And I want to make something very clear if it's not already clear. I'm not plugging in to the ln. I am literally swapping. I'm exchanging the ln for a pre-selected value. Everywhere I see an lnc, I'm going to replace that with a 5. So all of the ln's are going to disappear. This is another one where if you try to use your calculator, you say, oh, I'm just going to take these numbers and stick them into my calculator. You might be tempted because you've got an ln button on your calculator. That will sink your ship in an instant. You're going to go down like the Titanic if you do that. Okay? And there's no lifeboat. So you got ln of a. ln of a is 2. ln of b is 3. So notice I'm literally swapping out my logarithms. Be careful with that negative 1 on the outside. I don't want to forget about it. Remember I used to call that little brother? All right, don't forget about your little brother. Go back and pick him up. ln of b is 3. That's the denominator. And ln of c is 5. And now you're done. Your answer is 5 over negative 8, or I would just write it as negative 5/8. But you know what? I don't care. I've said this a lot going back to January, February. You can put the negative on the bottom. You can put the negative on the top. You can put the negative out in front. But if the answer is negative, it better be there somewhere. Okay. That's why I didn't want to forget that negative 1 out here. That's what changed my value into a negative. Yeah, it became a negative 8 in the denominator. Okay, that is your introduction to the properties. Although we only have one section titled Properties of Logarithms, we are now going to be expected, or you are now going to be expected to use the properties for the last couple sections in the book. Once you learn the laws or the properties, now you're expected to follow them. So even though I'm saying it's over for today, it's not really over. Okay, we'll see you tomorrow. Bye. Take care.